Welcome everyone. This video is our intro to a brand new unit, which is electricity. Now, for AP Physics 1, we're going to focus on static electricity, but if you're getting into circuits or you're interested in learning about electric fields, electromagnetism, this is still going to be your starting point. Charge. Charge is a fundamental property that is noticed when you really zoom in and you see what makes up all normal material. So we're going to talk about what charge is and also quickly go over conductors and insulators. Now, this slide might be a lot of review based on your background knowledge in chemistry or physical science, but let's make sure we're all on the same page. If we zoom in on matter, we see, and by matter I mean anything that has mass, if we zoom in, it's always made up of these particles known as atoms. And atoms themselves are made up of three different pieces: protons, neutrons, and electrons. All right, now in an atom, the protons and neutrons are in the center area known as the nucleus, and the electrons are orbiting around the outside. This model that I have here is totally fine for this topic. The key thing to know is that it's the electrons that are on the outside, they're moving around, and the protons and neutrons are locked in place. Now, when we look at these individual pieces, a fundamental property comes into play that we haven't really seen before, and that fundamental property is known as charge. Charge is often missed on our large-scale analysis or experience, but in the small scale, charge reigns supreme. Okay, there's two types of charge. There's positive charge and negative charge. Electrons have a negative charge. Instead of writing negative all the time, you'll often just see like a little minus sign. Protons have a positive charge. All right. Now, protons and electrons are very different. Protons, for example, are much more massive. However, it does turn out that protons and electrons both have the same amount, the same quantity of charge, but they have the two different types. Okay, protons, of course, positive, electrons negative, but they have the same number of charge. Just one is the positive type, one is the negative type. By interactions, we see that if you have the same type of charge, whether positive and positive or negative and negative, those two charges repel each other. They feel a force that's in the opposite direction, a repelling force. We'll get into that force a little later. So positives and positives repel, negatives and negatives repel. If you have two objects with the opposite charge, one positive, one negative, or one negative, one positive, they feel an attractive force. If I just showed you two particles and you saw or you were told that they are repelling, that actually does not tell you information about this individual particle, whether it's positive or negative. What you would know for sure is that these two things must have the same charge. Now, charge is measured in something known as coulombs, often abbreviated as uppercase C. 1 coulomb of charge is actually a huge number of electrons. In fact, the charge of an individual electron is, well, therefore going to be a very small number, 1.6 times 10 to the negative 19 coulombs. This is actually what you see on the AP Physics 1 equation sheet. Electrons, again, have a negative amount of charge. They just represent this as the magnitude, though, just the number. Remember, protons have the same amount of positive charge. So for an electron, it's 1.6 times 10 to the negative 19. It'd be a negative value. For a proton, though, it would be positive 1.6 times 10 to the negative 19. Again, a 1 coulomb is a huge amount of charge. 1 coulomb across your heart could be fatal. Okay, now let's get into charge and how we go about looking at charge in objects. For atoms, the structure turns out to be very important because, as we mentioned, protons and neutrons are in the nucleus. They are locked in place. There's something called the strong nuclear force that holds that nucleus together. They are bound together. Okay, these protons and neutrons cannot easily move. It requires a tremendous amount of energy. However, these electrons, they're orbiting around, they're moving around. Some of them are very far away. It's pretty easy for electrons, sometimes the term is drift, to drift around depending on the material, whereas the protons and neutrons are always locked in place. Because of this key idea here, the electrons are the things that are capable of moving. That is how things can have an overall positive or an overall negative charge. It's always the possible movement of electrons that could give something a total amount of charge. There's a term known as something being neutral. If something is neutral, if I say the table in front of you has a neutral charge, that means it has the same number of positives and negative charges. Neutrons have no charge. Okay, so this object right here, let's say this object was neutral. I gotta change my color pen. If it's neutral, like I said, that means it has the same number of positives and negative charges. You might see a diagram like this: positive, negative, positive, negative, positive, negative. This is not meant to represent, oh, this thing has 3 protons and 3 electrons. They're kind of representing, oh, there's an even number of pluses and minuses, so it's neutral. If instead an object was negatively charged, negatively charged, good thing I didn't misspell it. Well, and maybe we see a diagram like this. Again, that's not trying to imply there's only 4 electrons, but you see there's a lot of minuses. There's more negative charges. Last thing, if something is positively charged, positively, you might see something like this. Again, not trying to imply there's only 4 protons or even that there's just 4 additional. Just means there's more pluses and minuses. It's positively charged. Now, the key idea, something becomes negatively charged if it gains electrons, because it's only the electrons that are able to easily move. Something becomes positively charged not because it gained protons, because it lost electrons. Here's what I mean. If I have my neutral object and I take away these electrons, I take some little tweezers and I pluck them out. That's a joke. There's positive charges left. That's how you make something positively charged. You never make something positively charged by adding protons. Okay, so that's the basics between positive charge and negative charge and neutral charge. Let's talk about insulators and conductors. These are just terms to describe really how easily something can become charged or how easily electrons are able to move around. If something is an insulator, that means electrons cannot easily move around. Okay, so if electrons cannot easily move in a material, that material is called an insulator. Plastics, for example, are an example of electric insulators. Plastics are made up of chains of carbon and hydrogen. Carbon only has 6 electrons. Those electrons are pretty close to that nucleus. They're often bound tightly with these other atoms. So those electrons can't really move easily. They're kind of tied down in these bonds, as well as just being close to their nucleus. Metals, for example, have electrons that are really far away from the nucleus. They have not as many bonds or not as many strong bonds connecting them. If electrons can easily move in a material, like in metals, this right here is a representation of copper, it's known as a conductor. Okay. Now, just because something is an insulator does not mean it's incapable of getting a charge or having electrons move through. It's just more difficult. Okay. I have one little demonstration I want to show you just to end with. I have a sweater here and a balloon and a wall. Now, all of these things are classically insulators. Okay. Cloth, cotton, plastic or rubber in a balloon, drywall are all insulators. If I take the balloon, notice these are all neutral. If I rub it, there's something known as charging by friction. A balloon happens to strip electrons away from material. Now notice what happens. This sweater is positively charged because it lost electrons. And the balloon, at least this left side, is now negatively charged. These two things have opposite charges. They attract. Now, the wall, like I said, is an insulator. It's not easy for these electrons to move. But if I bring something that's very negatively charged, well, that's a lot of repelling, and it will make those electrons slide to the right. Again, notice, nowhere did these protons move because those protons are locked in place. This is why you can sometimes make a balloon stick to a wall, because all those electrons that piled up on one side, remember the balloon is a bit of an insulator, so these electrons aren't able to flow around the balloon. They're kind of stuck here. But they repelled a whole bunch of these electrons, so now this is positively charged. You have a little bit of attraction between the positive charges and the negative charges that are over here. Okay, but key things are, one, just because something's an insulator doesn't mean it can't get charged, and also those protons are never moving, and you charge something by giving or taking away electrons. Okay, we're going to look at more examples of charging later on. That's our video. Thanks for watching.